All right, guys, so let's look at some more examples here. The next one I would like you guys to try is Cn minus. Okay, so go through steps 1 through 4, and then let's see, what do we come up with? So for step number 1, count the number of total valence electrons. So for carbon, we have 4. For nitrogen, we have 5. And notice in this one, this molecule actually has a charge on it, right? It's a negative charge. So we add another electron to this. And this gives us a total of 10 electrons, okay? So you can have molecules that have charges on them, and then you just have to either add an electron. If this one is like, for example, a -1, so you would add 1 electron. A -2 charge means you would add 2 electrons. If it was a positive charge, then you would subtract that many electrons from the overall count, okay? Let's build a framework. Next step. So this is just 2 atoms, so you can just write them side by side. And then the next step is to add bonds. So let's do that. 1 bond takes care of 2 electrons. So this will be -2. We're left with 8 electrons, right? Step number 4, we're going to start by adding electrons to each of those atoms to complete the octet. So let's do it. One pair, so 2, 4, 6, and 8, right? 2, 4, 6, and 8. All right. Well, that takes care of all my valence electrons. But now I notice that my carbon is not happy because it doesn't have a full octet. So how am I going to complete this octet? Well, the only electrons that I have are the lone pairs around the nitrogen. And I need to 4 more electrons to complete the octet for carbon. So let's take this lone pair, let's take that lone pair, bring it in the middle, and actually make bonds. Okay, so let's do this. 1, 2, 3, nitrogen. Nitrogen still has a lone pair, carbon still has a lone pair. Let's count. 2, 4, 6, 8. We have 8 electrons for carbon. 2, 4, 6, 8. We have 8 electrons for nitrogen, right? And overall, we have 2, 4, 6, 8, 10 electrons that we have shown in this entire molecule, which is exactly what we started off with, right? This is a good Lewis structure. All atoms now have a full octets. We have used up all of our electrons. One more thing you want to do for this particular molecule, it has a charge on it. So when molecules have charges on them, we put square parentheses around that molecule, and then we put the charge on the outside of it. Okay, so if it had been a positive charge, you just put a positive charge, but you must put them in square parentheses. Okay, next example. Let us do PbR3. Pause the video, try it out on your own first, and then we'll come back and do it together. Okay, so phosphorus has 5 valence electrons. Whoops. Bromine has 7. And there are 3 bromines. So it'll be 3 times 7. So that's 3 times 7 is 21 plus 5 is 26 valence electrons, right? Now in terms of our structure building, I don't see a carbon in here, so we can't really put that as a central atom. I don't even see any hydrogens in here, so hydrogens are normally outer atoms. But what do we do with this one? So in this one, we follow that rule where we put the more electronegative atom on the outside, right? And if you follow the periodic table, in terms of the positions of these two particular elements, bromine is more towards the right of the of phosphorus than it is than phosphorus, right? So bromine is going to be more electronegative. Okay, so phosphorus ends up being in the middle. Place our bromines. 3 bromines. All right, there's our framework. Let's start putting bonds. Step number 3. 2, 4, 6. That takes care of 6 electrons. We're down to 20 electrons. Okay, now the time is to put lone pairs on each of our atoms to complete the octet, starting from the outer atoms first. So let's cover the bromines. 2, 4, 6, 8, 10, 12, 14, 16, 18. That takes care of 18 electrons. We're left with 2. Well, our bromines are happy, all of them. Phosphorus isn't, right? Phosphorus only has 6 electrons in the 3 bonds around it. So we put one more pair of electrons on the phosphorus, and that takes care of our last 2 electrons. We're down to 0. Okay. Now in this case, all of our atoms are happy. They've got a completed octet. This is a good Lewis structure. Okay. Next example. Did we do NH3 already? I believe we did. Did we? Yes, we did. We did NH3. Okay. Let us do SF6. Okay. SF6 is the next one. Okay, guys, I'm not sure where that recording stopped, but I just realized it stopped somewhere in the middle. So let's just make sure you guys have got this covered. If you have CN minus, so remember we got to put square parentheses around that one, and then the negative sign goes on the outside of it. The next example we did was PB3. We had a total of 26 valence electrons in this one. The structure, there's no carbons in here, so we can't put a carbon in the middle. There's no hydrogens in here, so there's no outer atom of a hydrogen in this one. So for this particular molecule, we have to resort to electronegativities, and bromine is more towards the right of phosphorus on the periodic table. So bromines are going to be on the outer side of the framework of this molecule, and phosphorus ends up being the central atom. Okay, and then we start putting our bonds in here. So 2, 4, and 6. 6 electrons used to make 3 bonds. I subtracted 6, left with 20 electrons. And then you start putting your lone pairs, starting with the outer atoms first to complete the octet. So 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons that I put around the bromines. Leaves me with 2 electrons. And then the octets for the bromines are good. Phosphorus is missing a pair of electrons, so we put that lone pair on the phosphorus, subtract the 2, and we're down to 0. So this was the structure for PB3. Okay, the next one that we're doing is SF6. So let's do this. Sulfur has a total of 6 valence electrons. Fluorine has 7 valence electrons, and then there's 6 of them in this one. So 6 times 7 is 42, plus 6 is 48 valence electrons. So following our electronegativity rule to build our framework, fluorine is the most electronegative atom on the periodic table, so it has to be on the outside. Sulfur ends up in the middle. We'll put 6 fluorines around this sulfur. Okay, there it is. There's your framework. I'm just going to space these out just a little bit more. Okay, all right, so there's our framework. Now we start putting bonds here. So 2, 4, 6, 8, 10, 12. Okay, well, now you're thinking, let me just write this out. So 36 electrons left, right? You're probably thinking, I just put way too many electrons around the sulfur, right? Because remember I said octets only. Octets means 8 electrons. Well, we just put 12 electrons around sulfur. So here is a little bit of an exception to that octet rule. Okay, it's going to be, let's see, let's add it over here. Actually, let's just make it as a separate point here. Okay, so sulfur, bromine, actually mostly sulfur, chlorine, and iodine are exceptions. They will have octets, but they can actually take more than the octet. Okay, and I should put phosphorus here too. Okay, so octets are minimum for these guys, but they can take more than the octet. Sulfur and phosphorus are going to be the more common ones. Sulfur can take up to a maximum of 6 bonds, which means 12 electrons. Okay, and phosphorus can take a maximum of 5 bonds, which means 10 electrons. So don't be alarmed if you end up with such awkward looking structures. All right, back to that example. Okay, so let's do this. So now we've put our bonds in here. So now we got to complete the octet by putting lone pairs, starting with the outer atoms. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. All 36 electrons are taken care of. Every single one of my atoms is happy. At least the fluorines are happy, and sulfur is just super happy, right? Because it's got its octet and then some. Okay, this is a good Lewis structure. All right, one more example before we move on to the next set of rules. So we will do NO3 minus. Okay, so I will actually stop the video here because it's going to be a bit of a longer example, and then we'll continue this one in the next video.